Hello, in this video we're going to look at the dynamic pricing strategy. This is the practice of changing prices often in response to changing market conditions. Some highways, for example, change tolls to ensure there is no congestion. Uber changes fares based on weather conditions, rush hour traffic, and other special events. And the basic idea is you're going to charge a higher price during higher demand, peak demand, or if there's a surge in demand. We're going to start with the tennis facility that has daily inverse demand during Friday through Sunday given by the following. Price equals A minus 0.5 Q. We're going to assume the value of A takes on the following values. On Friday, A equals 100. Saturday, A equals 160. And on Sunday, A equals 130. We're going to assume the tennis facility's marginal cost is 0, so MC equals 0. If we were going to do non-dynamic pricing and not respond to changes in demand, the facility might use the average value of A. So the average of these three values here, we got 390 divided by 3. A will just equal 130. Okay, so this is where this 130 comes from. It's just the average of these three values. The firm will get marginal revenue, which is just the inverse demand with a slope that is twice as steep. So it's 2 times 0.5. That's why we have just a 1 in front of the Q here. And setting marginal revenue equal to marginal cost. Q equals 130. Plugging this 130 back into the inverse demand, the firm charges a price of $65. Its daily revenue, 65 times 130 is $8,450. And over 3 days, Friday, Saturday, and Sunday, it'll have 3 times that amount, or $25,350 of revenue. Now let's look at dynamic pricing. The facility uses the value of A on each day. So again, we're just reminding ourselves what A equals on Friday through Sunday. And so this is probably the best way to solve it. Let's get marginal revenue, which is just inverse demand with a slope that is twice as steep. Let's set marginal revenue equal to marginal cost, and we're going to solve for Q as a function of A. So in this case, Q equals A. The quantity of output will equal A. And as a result, let's get the inverse demand also as a function of A. So since Q equals A, I'm going to make a substitution in the inverse demand and set Q equal to A. So on Friday, Q equals A and A is 100, so the firm will sell 100 units. And the price here, plugging this 100 into the inverse demand, when A is 100, we get a price of $50. And revenue on that day is $5,000. Saturday, A equals 160. So plugging that A value into the inverse demand and then evaluating to get the price, we get a price of $80. So higher demand, slightly higher price. And the revenue earned on that day is $12,800. On Sunday, A drops to 130. So our output, the number of units we're going to sell is 130. And the price here will now be $65. The revenue on Sunday is $8,450. So over 3 days, adding up 5,000 plus 12,800 plus 8,450, we get 3 days of revenue that is slightly higher than if we engaged in non-dynamic pricing. Okay, that's it. I hope you found this video helpful.